Looking at number 5, it says find the acute angle theta in radians and in degrees where the cosine of theta equals 0.42. So there's different ways you can think about this. If you like to visualize things, you can put 0.42 as 0.42 over 1. So since we're looking for an acute angle, we can think that it's going to be in quadrant 1, or you just have a regular right triangle. So here's your theta adjacent over hypotenuse. So you have to solve for this angle theta. How do you do that, right? You're like cosine theta equals adjacent over hypotenuse, which we already have. And then you have to get theta by itself, which is taking inverse cosine of both sides, right? So do this, and you get theta equals inverse cosine of 0.42. If you are in radian mode, you will get 1.137. If you're in degree mode, you will get 65.165 degrees. Okay, so that's how you get your answers in two different unit measures. So note that you could have just taken inverse cosine of both sides from the get-go because you recognize that it's an acute angle and you can just go ahead and do that. Number 6, we didn't go over it, so you can skip number 6, but just for future reference, whether it's for SAT, ACT, you might want to know it, and that is arc length is equal to r theta, where theta is in radian mode, or radian angle measure. So central angle of a circle with radius 9 centimeters intercepts an arc of 10.35 centimeters. Find theta. So the arc length is 10.35, and the radius is 9, so we're looking for theta. So if you divide both sides by 9, you get 1.15, and that is how much the central angle is in radians. Again, you don't have to worry about seeing a question like number 6 on our test. Okay, number 6 says to solve the right triangle. That means find all the missing parts, whether it's angles or side lengths, where the hypotenuse C is 35 and the side A is 25. So I'll just go down and label that CA. You can make either one A, right, and then the other one's going to be B. If you use Pythagorean theorem, you're going to end up with square root of 600, which gives you 10 root 6. Okay, so note that I've solved for all the sides. I really just had to solve for side B, the missing side, and that was 10 root 6. So I have that, but now I have to solve for the angle measures. So when you label these across from side B, do you remember? It's going to be my angle B, capital B. Across from side A is going to be my angle A, and across from side C is going to be my angle C. That's just standard notation. So we need to figure out the measurement of angle B and angle A, because we know that angle C, right, is going to be 90 degrees. So again, so far we know that B is 10 root 6, and angle C is 90 degrees. I'm trying to figure out what angle A is and what angle B is. Note that if I solve for one of them, right, then you can just subtract from 180 the other two angles, or subtract from 90 to find the third angle. So you just pick an angle. I'll just go ahead and pick angle B, and you can pick whichever one you want. I'll just pick these two side lengths. So I have adjacent over hypotenuse. So that would be a cosine relationship. Again, you could have picked sine relationship or tangent relationship. So I get cosine of theta is equal to adjacent over hypotenuse. So to get theta by itself, I take the inverse cosine. And when I do this, and I'm in degree mode, I get theta, right, is about 44.415 degrees. So that is going to be my angle B. So angle B is going to be 44.415 degrees. And then I can just subtract from 90 44.415 degrees, and I get 45.585 degrees. So that is your final answer, because whatever this angle is, right, the other angle is going to be the complement. Since in a triangle, all three angles need to add up to 180, but we already have the 90, so the two angles need to add up to the remaining 90 degrees. Number 8 says find the altitude of an isosceles triangle with a base angle of 18 degrees. So these are called the base angle, and a base length of 10 meters. So I'm trying to figure out what this is. This whole thing is, the base is 10, but it's split in half, so this part right here will be 5. So I'm trying to figure out what the altitude is. I'll call that x. So notice I have a right triangle here, and I'm really solving for that right triangle for this x value. So if I stand at the angle, I have my opposite and adjacent, so that's a tangent relationship. Tangent of 18 degrees is opposite over adjacent. X is equal to 5 tangent of 18 degrees. And if I plug that into my calculator in degree mode, I get 1.625, and it's in meters. So I'm going to keep that in meters. I also want to remind you, for word problems, you need to remember angles of elevation and angles of depression. So a quick recap, it's always from the horizontal. Angle of elevation is from the horizontal looking up. Angle of depression is from the horizontal, right, looking down. Number 9, it says give two answers for theta such that theta is between 0 to 360 degrees, meaning if you look at your unit circle, you want it to go from 0 to 360 degrees. Notice that the restrictions are given to you in degrees, so you need to be in degree mode. So let's take a look at the following. Sine theta is equal to 0.9511. I can take inverse sine of both sides, and I'm in degree mode, so I get theta is equal to about 72 degrees. Okay, we're actually rounding to the nearest 3 decimal places, so let's rewrite that as 72.008 degrees. That's only one of my answers. Notice that when sine is positive, right, all students take calculus, when sine is positive, sine will be positive in quadrants 1 and 2. So I've gotten my quadrant 1 answer of 72.008 degrees, but I need to figure out my quadrant 2 answer. So how can we find that? So notice that my reference angle is going to be the same. That's 72.008. So what I'm looking for is just 180 minus 72.008. So again, to find the second angle, I can do 180 minus 72.008 because I'm looking for that quadrant 2 angle, and that gives me 107.992 degrees. So these are your quadrant 1 and quadrant 2 angles that give you this statement to be true. Okay, so again, you take the inverse of both sides, and then you're going to get an angle. Figure out what the reference angle is and place it in the correct quadrants. All students take calculus. You're going to get 2 quadrants that give you the positive or negative value of the one that matches what's given to you, and you have to compute it out. Okay, secant theta is equal to 1.0711. So if you see secant theta, cosecant theta, or cotangent theta, rewrite the whole thing in terms of the reciprocal. So that means cosine of theta will be 1 over your ratio. So that's what I have. So now I can take the inverse cosine of both sides. And so I get theta is equal to 21 degrees. Actually, again, it's rounded to 3 decimal places, so it's going to be 20.994 degrees. So notice that I have 20.994 degrees, and that is actually my reference angle because that's an angle, it's acute, and it's created between the x-axis, right? But notice I should have a second answer, right? Because I'm going to get 2 answers. Well, cosine is positive. Where is cosine positive? Cosine is positive in, all students take calculus, quadrants 1 and 4. So I need to figure out this angle here that has the same reference angle. So this is a reference angle. How big is this angle here? Well, it's really just 360 short of 20.994. So if I do 360 minus 20.994 on our calculator, we get 339.006 degrees. So my 2 answers that make this statement true is going to be 20.994 degrees and 339.006 degrees.